Okay, here we go. Now for shop job 2601, we're back to our standard push buttons. We have one for a stop, one for a start, and one for a jog. And then we're going to be using a selector switch for our actual direction. We're going to add in a maintenance feature. And what this is going to do, this is very common in motors out in the field, that after so many starts, we're going to want to flag the someone that maintenance needs to happen on this particular motor. Now we're just going to do it by way of actually disabling the motor. In the field, you wouldn't disable the motor. You'd probably have an alarm or some sort of message that would pop up that would show that that motor needed maintenance. But since we don't have an operator interface, we're not going to be doing that. We're just going to be disabling the motor until the maintenance is performed. Then we have to have a way to reset it. We're going to use our 2-position selector switch here to be able to reset the motor. And everything else is pretty much the same. So we're going to have a automatic start feature like we've had for the last several jobs. And of course, if we're starting it in the same direction, we don't even have to wait. It'll go ahead and start in that direction. One thing that we have added here is we're kind of assuming that when we push the start button that motor contact is going to pull in a very timely fashion. And for the most part it does. But there are, either for very large motors or for valves in particular, when you invoke the valve to change position, you might have to wait a certain amount of time before it actually makes it to that position. You can imagine the valve might be in transition where it's moving from an open position to a closed position, and that takes a little bit of time, especially for large valves. So we're going to incorporate a wait or a time delay between our start and our stop on this motor. And then we are going to, like I said earlier, keep track of the number of total starts. We don't care whether they're forward or reverse, just a combined. And when we exceed 2,000 starts, we want to disable this motor, and the motor will stay disabled until we reset it with that reset switch. The lights will be configured the same. They will flash on the newly commanded direction change, and of course you'll have the red and the green lights just to show the status of the motor. So let's come over and look at 2501. We're just going to convert this to 2601. So we'll save this as 2601. And we'll change the description here. Probably going to need to move this description as well, because we don't need our code here at the top for the one-shot, one-push-button challenge that we had on the previous job. So I'm going to go ahead and just cut this out and paste it in on a rung lower. So we're not going to need this rung. I'm holding down the shift key and using my down arrow. We're not going to need that rung or that rung. So I'm going to go ahead and hit delete there, and we're back to where we were at 2401. And then I'm going to paste my comment in here. Okay. So now we want to go back to our original stop, which was I:0.0/4. Okay. And we want to go back to our original start, I:0.0/5. Okay. And I should rename this to just start. And this should be start motor. Okay. And of course we're going to need the rest of these settings, how they are for the auto function. And now we're going to come down here and do the same. So I:0.0/4, and here I:0.0/5. Okay. So stop and start motor. Of course, this needs to be changed back to an examine if closed. because closed means it's okay to start the motor for a stop push button. Okay. All right. So now we've got this set back to at least the 2401 standard. And let's see. So our definition for forward and reverse will not have changed. Now here we can actually leave this because I like that functionality from what we had from our previous job. And so then we have our flashing lights. Okay, so now all we need to do is implement the few new things that we've added for this. So we had 2 counters before, but we only need 1, and it's just going to be a start counter. So I'm just going to use this first one here. Come over to my user tab, get my rung branch, and put that there, and then this is going to move up to here. And then we won't need the second counter. Let's go ahead and delete that, okay? And then this will no longer be the forward counter, it'll just be the start counter. Okay. And then here we only need to reset 1 counter, we don't need to reset them both. Okay. So now this button is actually going to reset our counter. We wanted to count to 2000, correct? So 2000 will give us our maintenance flag, which we want to disable the motor. Okay. And then this, if we're closed, let's see, let's look at our job sheet again. A, which is 1, should be auto, and 0 should be our maintenance mode. Okay, so we want to come back over here, and we want to test for 0 or examine if open. And so we want to change this type to an open. Okay. Okay. So if we go to that B position on a selector switch, we're going to clear out our timer, our counter, and maintenance counter, and then our counter done will be cleared. So we need to use our counter done here to disable the motor, and we can do that up here. So we already have a disabler on the overload. We can add another disabler here. I'm going to go ahead and increase this so we can see it all. This is going to be my C5:0/DN, okay? And so that's my start counter, as long as it is not done. Okay, so we're examining to make sure that done is 0. We're testing for 0. If done is 1, that means it has reached 2000, and we will disable the motor then. Okay, and we also want that up here for forward. Okay, drag this over so they're in the same order. Okay, so now we have added our disabler in there for 2000 starts, and it forces us to go to a maintenance mode. And this right here is our 2-position selector switch that will clear out and let us know that we're done with maintenance mode. Okay. Let's see. Did I have anything on the lights for that? No, I didn't. Okay. There was a possibility that I might have wanted the yellow light to flash when we're in maintenance mode, but I didn't have that on this one. Okay. And Okay, so we've got that done. The only thing that we have to worry about is if we don't reach our status. See, here we're actually holding based on our selection. And so we're driving an output that is, we're just assuming that it's getting there. We don't know if it hasn't gotten there or not. So when we look down, the lights are going to tell us whether it got there, but the actual motor doesn't fail if the light doesn't come on. So here, if I'm commanding it to run and I'm not in direction change and I'm not in reverse, it's just going to drive that output, and it's going to continue to drive it even if the motor never starts. So we actually want to incorporate in that time delay. We're going to give the motor 4 seconds to start. If it doesn't start, we're actually going to disable that output or de-energize that output. Okay, so like I said, I like my timers and counters to be down here at the bottom, and I also kind of like the timers to be together and the counters to be together. So I'm going to insert a rung just below here. Let's see. Oh, there's what I want to do. Okay, so I'm going to want a timer in here, and I'm going to keep using on delay timer, and this is going to be a T4:1. It's got to be a different register than this one. Okay, so T4:1 is the next one, and this is going to be a motor fail timer. Okay. No, I'm gonna change this name here. I don't like that. I'm gonna call this fail timer. Okay, and so now we need to just come up with the conditions of which we would think the motor has failed. Well, that is if I am driving the output, so O:0.0/3. Okay, so that's my forward direction, right? And I do not have my status contacts, I:0.0/7. Okay, so that would be a definition of a fail. Now, it doesn't happen right away. We have to wait the 4 seconds. So we need to set this to 4 seconds as well. Okay. And then we want to branch around this, so get a rung branch, because that's just for one direction. We want to do it for the other direction. And this is going to be O:0.0/4 for reverse. And we do not have the reverse set of contacts, I:0.0/8. Okay, so if it's one or the other, so we've driven the output to forward and we never got the status contacts back, we're going to start this timer. And when this timer's done, we're actually going to fail the motor as well. And here, if we drive the output into reverse and we never get those reverse status contacts back, we're also going to time for 4 seconds, and after 4 seconds we are going to fail the motor. Okay, so the motor fail is just going to be the fail timer being done. So that's just going to become another disabler up here at the top. Okay, so we already have one for the overload. We have one for our counter exceeding 2000. And now we want to add one more, and this is going to be T4:1. Remember, 1 is the fail timer, and it is done. Okay, so as long as it is not done, we're good to go. But if that timer is ever done, then that means that we have driven an output, not seen the contacts come back, and we want to stop driving that motor output. Okay, something bad might be happening in the field. Okay, and of course we want to do that same thing down here. All right, let's download this and try it out. So we have a 2-position selector switch that right now is in reverse. I can see that right here, and you can also see it over here. And our maintenance switch is in the auto mode, so that means that we're not resetting that counter. So here we're not resetting the counter, so the counter is due to count all of our starts. Okay, so we're going to come back up here at the top and we can watch this. I'm going to go ahead and hit the start button, and we should start in reverse. And hopefully you can kind of see, I put some red tape on it. This one's reverse right here. You'll be able to see that one move as well. Okay, so there's my reverse, and of course I can go in reverse as many times as I want, but if I try to all of a sudden go into forward, we still have our implementation from 2501 that forces me to wait, and then I had my automatic start, and we saw up here that is the motor starter that is now being energized. Okay, and again I'll switch directions here. Now you notice that time I didn't push stop, I just flipped my directions, and that killed the motor. Okay, so that looks good. All right, so now let's go down and let's test our maintenance. So we should have so many counts in here already. So we have about 10, forward and reverse. I'm going to make this, okay, and we're going to see the disable function happen here. Okay, so I'm going to stop this and then start it again. And if you notice, when I tried to start it, it immediately stopped it because we increased our count to 2,000, and then we came up here, and now we're disabling both forward and reverse. Reverse was the active state at that time. You can see it right here, but both forward and reverse are disabled. Okay, and as long as we don't change our reset button over here, we will be disabling the motor. Okay. Okay. So that will cover the maintenance portion. Now let's look at the failing of the motor. Actually, let's test the overload. We didn't do that for the last shop job, but the implementation has not changed, so we'll be able to test it here. I'm going to go ahead and push the overload test button. Okay, and let's do it for the other direction as well. So we'll have to wait for the timer to complete. Okay, and I'll test the overload. Okay, so now to test my status not pulling in, I'm actually going to have to unwire a wire from the PLC so we don't get the status in. Now, of course, if we were in class, the panels that we work on there have a switch on the front that we can throw the switch and do this test. But I'm going to break away here for a minute, unwire the inputs, and then we'll come back and test the fail logic. Okay, so now I have unwired the 24 volts going to 13s on both of our motor starters, and so we're never going to get that confirmation from the field. So I'm going to first select forward, and when I press the forward, you're going to notice that I will not get the white light that is going to indicate that those sets of contacts are closed because they don't have 24 volts going to them. And it's going to take 4 seconds, and then after 4 seconds it's going to fail the driving of the output because we're not getting a status back from the field. So we don't get the white light, and now after the 4-second timer, we disabled this. Of course, once we stop it, the timer also gets reset, so it only happens for one scan. And so that was for forward. Let's go ahead and check it for reverse. And I'll also scroll down here so you can see the logic for that timer actually operating. So here, we're going to drive the reverse, and we're never going to get the status because it doesn't have any control voltage on it, and so our timer is going to start. So you see there the output is being driven, but we don't get the status, and then therefore the timer is timed out. Okay, I've gone ahead and rewired the both of the 13s on our motor starters back to our control voltage so we can do a test. There's only one other thing that we need to implement on this, and that's the jog functionality. If you remember from the job sheet, it said that we had a stop button, a start button, and a jog button. Now jog is going to be the exact same implementation as I have right here, except it's not going to have this holding circuit. So I can just come here and hit Control C and then Control V, and it will paste another rung below it. Of course, we don't need this description, so we'll get rid of it. And we don't need the holding circuit because this is a jog. And then this needs to be changed to the jog button. Okay. And so we're going to go ahead and call this jog motor. Okay, call this jog. Okay. And of course, if we do it there, we're also going to need to do it here for reverse. And so I could copy this one, or I could copy this one here. I'm just going to go ahead and copy the reverse one here. Control C, Control V. And I want to get rid of this. And, oops, I want to do it for the lower one here. Get rid of this and change this to 6. Okay. And then if you remember, this is our run forward. We actually reserved a jog forward. So I believe that was 2. I guess I don't have it on this file. Yeah, because that was 1. So this will be our command for jog forward command. Okay. And if that's 2, let's make this one 3. Let's see. I want this actually to be up here. And I want this to still be at bit 1. And then it is this one down here that I want to be 3. And this is going to be jog reverse command. Okay. So now I have my jog forward and jog reverse. I need to fix this one. Okay, there we go. Okay, so I have a run forward, and I want to get rid of this. Don't only need 1. So I have my run forward command and my jog forward command. Okay, and I have my run reverse and jog reverse command, and I have all the other logic here that I need to examine. So here, my last forward and last reverse, that implementation should not change. Now here for direction change, we have our last direction was forward, and this is if we try to run in reverse, that's a definition of a direction change, or if we try to jog in reverse, that's a definition of direction change as well. Okay, so this is going to be my B3:0/3. What did I do wrong there? Oh, I was trying to type an address as an instruction. So I want to put the instruction in there and then B3:0/3. Okay, so there's run or jog in reverse will be a definition of a direction change. And then here, if my last direction was reverse, if I run forward or I try to jog forward, this will be, okay. So if I try to run forward or jog forward, that's my definition of a direction change. Okay. So that takes care of our direction change. Now let's look at where we actually drive the output. Okay. So there's my lights. So down here for trying to drive the output, we want to also add our jog functionality in down here. So B3:0/2. Okay, so jog forward or run forward, we're going to energize that output. As long as we're not in direction change and the other direction is not being driven. And then here, same thing, put a rung branch and make sure that we are not jogging in reverse. Okay, so here, if we're run reverse or jog reverse, either one, and we're not in direction change or in the other, driving the other direction, we'll go ahead and drive this direction. Okay, so that should take care of that. This is based on status, and that's based on the outputs, so that should all be good. Let's go ahead and download this, and we'll try our jog function. Okay, so I am going to select forward, and just making sure that my run forward works. Now let's make sure my jog forward works. That's good. I'm going to change directions here. And there, so I just tested my direction change with the jog button. And now I can jog in reverse. And I'm going to try just running in reverse. And I can still run in reverse. Okay. And then I want to test my jog to make sure if I don't have either direction selected that it will not jog. Okay, so I'm going to go offline here, and I want to show a way of cleaning up this because this is getting quite crowded, and there is a way for us to clean this up just a little bit. If you notice up here at the top, there is a whole bunch of code that's the same: e-stop, stop, not overload, not the counter being done, and not in the failure mode. For each one of these, there's one for forward one, there's one for a jog forward, there's one for a run reverse and a jog reverse. Okay, and all that code is the same. We can actually simplify this. I'm going to go up here to the top, and I'm going to add a rung. And I'm going to go ahead and make it the very top here. Of course, if I do that, I'm going to have to move my description. And what I want to do is, if I put focus on the first one, hold down the shift key and select all of those, I can drag them up to this rung up here. Okay, so that copied them up there. And now what I want to do is I just want to write that to a binary register that I can use later in the program for all of those. Okay, so I'm going to use B3:0/9. Okay, we haven't used that yet. And this is going to just be my disablers. Okay. So all of my disablers are stored up in this binary that now I can use down here at the bottom. Okay. So here I can delete all of those. Now if this goes to a 1, that means I'm disabled. So that means if I'm a 0, I'm not disabled. So I want to test for 0 or test for open, examine if open, and I want to test this address. If I bring that address down here, now I have all of my disablers built up into that one binary. And I can do the same for all of these. Not that far. Okay, right here. Okay. So all the disablers, and then here are my two enablers and selections that make that rung unique. Okay, go ahead and get rid of all of these except for this right here. Okay, and then the last one is the reverse jog. Okay, and if you notice, that cleaned this up quite a bit and made my rungs not nearly so wide. Everything else should be the same. We'll go ahead and check this, download it to make sure we haven't lost any functionality. Okay, so we're going to watch up here. I'm going to do some tests before I even try to start the motor. If I push the E-stop, that is disabling, right? Out. I actually implemented this wrong. This should, 1 means good. I did it backwards, okay? So 1 means good, so this should all be the examine if closed. Okay. And here, change the type, examine if closed. Examine if closed, and this one. So even the instructor gets confused sometimes. All right, let's go ahead and download this. So now let's check our implementation up here at the top before I even try to start the motor. If this is a 1, that means it's good. So it's just like the E-stop. If this is a 1, that's good. That means we're not disabling. So if I push E-stop, I should lose my disabler right here. Okay. If I push stop, I should lose that. Okay. I'm going to push the overload button to test. And of course, if my timer or my counter also go off, that will disable our function. So let's go ahead and test this to make sure that it's running. I don't have any direction selected, so I'm going to hit forward. Okay, so that's working fine. I'll go ahead and test my jog button as well. That's still working just fine. And I'm going to hit my stop, e-stop. That's not letting me stop there. And so now, test that. The stop button is working just fine. The e-stop button is working just fine. Okay. And I'm going to flip directions here and try to start. And I get my implementation for alerting the operator that they have to wait, and then it'll automatically start. So all that's working. Okay, let's test out our other two items, or at least one of our items. I won't unwire to test our failed timer again. But here, I'm going to come to just below our failure time. I'm going to hit stop and then hit start. And if you notice, I disabled myself right away. And we'll come back up here and look at the top. And you see, as long as I don't reset that, I will never allow the motor to start in either direction until I come here and reset my counter, and now I can go ahead and start the motor again. Okay, so that is Shop Job 2601. I hope that helps, and we'll see you in the next lesson.